Hello, you guys. This is Miss Gariano. This is just going to be a bit of a video lecture tutorial that will help you fill out the notes on the back side of your note sheet that you got earlier today in class. So in class, we filled out the front side that talked about different kinds of discontinuities we could have with rational functions. And on the back side, we are going, and in this video, we're going to be looking at a specific type of discontinuity, horizontal asymptotes. So again, I cannot stress enough that this video is meant to be just what you need. So feel free to pause, replay anything you need to make sure that you understand what we are talking about, what we are learning about. And there'll be some example problems that I'll go through, and then you'll be expected to fill the ones out on your worksheet. So without further ado, let's start. So to find horizontal asymptotes, you need to look at the degree of the numerator and denominator. So remember, a rational function is just a fraction or a division problem involving two polynomials. So if you remember right from last semester, when we say degree, we're talking about the largest exponent of a polynomial. So when we're looking at horizontal asymptotes, we're just comparing the degree of the polynomial that's in the numerator of our fraction with the degree of the polynomial in the denominator. So at this point, for problems 1, 2, and 3 for part A, you'll just need to go through and decide what degree is this expression, and this expression. So I would go ahead and pause the video, take the time to figure out the degree, and then we can continue. Alright, so I'm assuming that you have found the degree for 1, 2, and 3 above. So next we are going to go on to the second part of this note section. Alright, so we are going to let the highest degree of the numerator be represented by m, the letter m, and the highest degree sorry, I just had a blank on how to spell degree. Luckily it was over here. Highest. Did I still mess it up? Yeah. Back up. Highest degree of, oh, they already have degree here. But anyway, highest degree of the denominator be represented by the letter n. So when we're talking about our polynomial function, or for our rational functions, when we're looking at the degree, so if I have something like x squared plus 3x over x cubed plus 1, the degree in the numerator, the m, would be 2, so that would be our m, and the degree of the denominator would be n. So that's what we're talking about with these letters. But we're using letters to talk about it so that it's in a general case. So if m is greater than n, so that would not be in the case of this little example over here, then there's not going to be a horizontal asymptote. So there is no horizontal asymptote. And the reason for that, I kind of like to think, so if the numerator has a larger degree, it's kind of like the more powerful polynomial, and it's going to kind of beat up on, be the bully of the denominator, and so it's not going to let the denominator overpower it in a way that it would create a horizontal asymptote. So there just wouldn't be that kind of invisible line running horizontally on your graph if the degree of the numerator is higher than the degree of the denominator. Then if the degree of the numerator, so m, is less than n, so this number is less than this number, which is in the case of this one, then the horizontal asymptote is at y equals 0. So this was the general case we saw with our reciprocal functions, as long as we didn't shift the graph up or down. But if we had something of the form 2 over x, this degree is higher than this degree, so our asymptote was at 0. Then finally, if the degrees of our numerator and denominator, so this and this degree, are equal, so if this was an x squared instead, then the horizontal asymptote is the reduced fraction of the leading coefficients. So that means, so if this was like 2x squared and this was 3x cubed, except this would be like an x squared in this case, we would take these coefficients here for this bottom one, and we would do 2/3, or y equals 2/3 would be our asymptote, our horizontal asymptote. So you just take the coefficients in front of the leading coefficient, because it's the coefficient on the highest term, and you would simplify it if you can, and that would be your horizontal asymptote. Alright, so now that we have these definitions, hopefully you've written them down, let's look at some examples. Alright, so we want to find the horizontal asymptote for each of the rational functions below. So here's our problem. So for this first one, we need to determine what our m is, which is the degree of the numerator, and what the n is, which is the degree of the denominator. So our degree here is just 1, because it's x to the first power. And our degree in the denominator is also a 1. So since m equals n in this case, or our degrees are equal, that just means that our asymptote is going to be at the whatever the coefficients reduce down to. So I take these coefficients here. So the asymptote will be at y equals -2 over, there's an understood 1 right here, which is just -2. So my horizontal asymptote is at -2. Then for example number 2, again we need to identify the degree of the numerator. So this degree is just a 1 because it's x to the first power. And the degree here is the 2. So in this case, our m, which is the numerator number, is less than n because 1 is less than 2. So when the numerator is less than the denominator, you can again kind of think of like a bully situation. The denominator is more powerful because it has the higher degree. So the denominator is the part that gives us asymptotes. So the asymptote's going to overpower the numerator, and we're going to end up with a horizontal asymptote at y equals 0. All right, for example number 3, same thing. We want to identify the degree of the numerator and then the degree of the denominator. Here our degree is 2. Down here our degree is 1 because there's an understood 1 right here. So here we have m is greater than n since 2 is greater than 1. So when the numerator degree is larger, again, if we think of like a bully, it's more powerful, it's going to overpower the little scrawny denominator. And since the denominator is where the asymptote would come from, it gets overpowered, so there is none. So this one has no horizontal asymptote. All right, so hopefully you've written down those 3 examples, because now you get to try problem 3 on your guided notes. It's an ABC problem. Just remember to look for the degree of your numerator and denominator, then look at your notes on your note sheet to see what situation follows. And I hope you have a lovely rest of your night and weekend, and I will see you on class on Monday. Have a good day.